Hi folks, Joseph Kursky here with you to talk about loading, adding, and working with data for the Kenya T project, one of the 10 exercises on spatial reserves and associated with the GIS for Public Domain data book. What you want to do is start a new ArcGIS Pro project. And so once you do that, find a place for it. Find a logical place on your device to store that project. In GIS, it's very important to be organized about where your data is stored, where your projects are stored, where your images are stored, etc. I know that ArcGIS Pro, like a lot of other software, has a default location. Sometimes that default location isn't very meaningful and something that you can easily find later on. So don't just take the defaults. Once you've got a logical place for your project, your APRX, go ahead and now add the data into your project. How do you do that? For one thing, after you've downloaded the data from the public domain data sites, in this case the World Resources Institute or WRI, you're going to have a GeoDatabase. Once you start a project, one of the functions that you can use in a GIS is you can start it with a GBD. So the ArcGIS Pro project starts up with a GeoDatabase inside of it. And what you want to do is you want to load your data into that GeoDatabase by importing the layers that you've downloaded. So in my case, I've got a Kenya T 2022 GeoDatabase, and now I'm going to navigate to the place where I've stored my data. I've already unzipped that data because oftentimes spatial data is in zip format. Now keep in mind that sometimes data is streamed, and so these downloading procedures don't apply if you're streaming data in. That's a separate workflow. But in this case, I've got a GeoDatabase and I want to import my shapefiles, my external geodatabases, feature layers from those things, my images, whatever I've got, my CSV into a GeoDatabase. You don't have to do this, but I'm looking at where I've unzipped all of my DEM, my rainfall, my roads, my rivers, my urban areas, etc. And I'm looking at all of those places where I've got that stuff unzipped. So I've got a combination of vector data sets and raster data sets. I'm going to load that into the GeoDatabase. Again, you don't have to load it into a GeoDatabase, but it makes life easier. It makes your processes run faster. It allows you to easily select things if things are all in a GeoDatabase or a set of GeoDatabases. There's no reason to have just one GeoDatabase for a project in ArcGIS Pro. But in this case, let's keep it simple. Let's keep one GeoDatabase for the project inside ArcGIS Pro. So now I'm going to import all of the data into my GeoDatabase. Again, I've got, in this particular case, I've got, I believe it's 9 vector layers and 2 raster layers into that GeoDatabase. The 2 raster layers are the total annual precipitation and the digital elevation model, or the DEM. The roads, the urban areas, the other data sets are actually vector files. But no worries, GeoDatabases can handle raster and vector data, so now I'm going to import. But before I do, I'm just having you check the environment workspace to make sure that your default workspace is actually the GeoDatabase. That makes, again, life a little bit easier, so just go to the environment setting, as I just did. And now I'm going to import my feature class. In this case, I'm going to choose one of the vector layers and import that as a feature class into the GeoDatabase. Again, I've got to find that location, and by setting the environment variables, you can sidestep some of this navigating as I'm doing to the different locations on my device where I've got that data downloaded. Ideally, you want to download it to the same location so you don't have to go searching all over your device. So that's what I've done. I've downloaded it all into this Kenya T folder, and then underneath that I've got all the data unzipped. So now I'm going to add the feature class agriculture to my GeoDatabase. So I've started with agriculture. I'm loading that in using the feature class to feature class geoprocessing tool, which is one of the analytical tools inside ArcGIS Pro. Once I do that, I've got to be careful about my output name, so I'm going to name that appropriately. I'll probably put agriculture for my output name. Let's type that in right here, agriculture. Great. And once I've got that, that's good. I don't need to filter the data or anything like that, although I could, but I'm going to go ahead and leave it as is and import the whole thing, and I'm going to run that. And now it's basically saying, okay, that shapefile, in this case, the agriculture shapefile, I'm going to load it as a feature class into a GeoDatabase. Something that's a little bit unnerving, you get that exclamation point that you saw. That's just saying the next time you run that, you can't name it feature class agriculture because you already have that. So again, now in the I like to keep that project pane for the catalog open at the right side there, as you just saw. So now I can keep track of what I've done so far and what I have to do. I'm going to take the district boundaries, the same procedure, feature class to feature class. I'm going to say input features district boundaries. I'm going to name my output feature class in my GeoDatabase district boundaries and run that. These aren't that big of a file, so they should import fairly easily. And you're basically, again, saving all of your layers into a GeoDatabase feature class or a grid or an image. We do have a couple of raster data sets as well. All right, so I've done agriculture and district boundaries so far. And now let's go ahead and proceed. The DEM, if I use the same function, feature class, it's saying, Joseph, you don't have any feature classes under DEM. Why? The DEM is a raster file, right? It's a grid of elevations. So you can't use that tool inside ArcGIS Pro for that data. You have to run something else that works for raster data. What are you going to do? You're going to close that geoprocessing tool and open a new tool, and you're going to search for and find and use the tool that can deal with raster data. This tool is called Raster to GeoDatabase, and as you can see here, it's asking me, okay, now that you're running raster, you got to point to a raster data set. And in our case, we have two. One's called the DEM at 250 meter resolution. My output GeoDatabase is going to be the same place where I stored my vectored layers. So I'm going to navigate to the place where I've got my GeoDatabase for my vector layers. And once I do that, there's my GDB or GeoDatabase. I'm going to store that DEM as not a feature layer, but it's going to be a raster layer inside that GeoDatabase. Of course, this one has the elevations for Kenya. Fascinating. Anyway, it's great to be able to do this, and I highly encourage, again, you to load all of the layers into a GeoDatabase. So now it's not showing in our project pane, P-A-N-E, not P-A-I-N. Haha, little geo joke there for you. It's not showing me that. So what I have to do is I have to right click on there, and there's a refresh button, which is unfortunately off the screen, but I clicked on refresh and now I can see the DEM in there. Okay, so now what do? I am now at the point where I'm going to import all of my other layers into that GeoDatabase. If it's a raster layer, you're going to have to use raster to GeoDatabase. If it's a vector layer, you're going to have to use feature to feature class inside the GeoDatabase. So right here, I'm going to pick, what am I going to pick? I'm going to pick total annual precipitation, since I'm still on the raster tool, and that was a raster data set showing obviously precipitation, and I'm going to name it effectively so I know what the name of it is. It's really important to be thoughtful about the locations of files and folders, but also the names of your layers, so that when you're running processes on them in the future, you'll be able to understand what layers you're dealing with. Just makes life a lot more easy. Geotechnologies is rather complicated. It really is, because you're dealing with the Earth and all of its complexity and all of its different feature layers and raster layers and image files and tools and workflows and the code behind the tools. So don't make it more difficult for yourself. Don't name things A1, A2, A3. Actually name them with meaningful names so that you can do what I'm doing here and being able to go to these different layers and choose them, and you know exactly what you're getting. Okay, now I've repeated that process and I've skipped ahead so that you're not watching me do that same process for all the layers, but now I've got all 11 layers, my 2 raster files and my 9 vector files in my GeoDatabase. Great. All right, so now I'm going to look at something else that's important once you bring data into a GIS, and that is looking at the spatial reference. In other words, the map projection. So I'm looking at the metadata for each one of these, and I'm seeing the spatial reference is unprojected GCS, Geographic Coordinate System, World Geodetic System 1984. That's a sure sign that that data is unprojected. Why do I care about that? Well, because if you're working in a GIS environment and you're doing calculations and you're doing spatial overlays, you want to have those data sets in a projected space. So I'm going to use WGS. I'm not going to use WGS 84. I'm going to use the Albers projection to cast my data sets into. That's the next part of this particular lab. So what do we do here? We have to project the data. Remember, define projection defines the data set as it exists now. So if a data set has no projection at all, no spatial reference, you have to define it. If it's already got a spatial reference on it or a spatial projection attached to it, you're going to need to project it into a different coordinate space. So let's just take one of these layers, for example. We started with agriculture when we imported, so let's start with agriculture here. If I start with agriculture, I'm going to see that, okay, I'm going to project the data, and I'm going to call it Albers, agriculture Albers. And so, okay, what coordinate system do I want to use? Well, our project is Kenya, and it's all Kenya. We're not dealing with any other place around the world. So I'm going to use a continental equal area projection, and I'm going to use not the North American Albers, but I'm going to use the Albers Africa equal area conic, so that my measurements for my areas that are suitable for tea cultivation, which oftentimes could be a very small area, I want to make those as spatially accurate as possible. So that's why I'm going to use a projected coordinate system. Now, unlike other labs and exercises in this spatial reserves set of exercises, I'm not going to have you, in this case, project every one of those individually. I want to extend your skills a bit. And so here we're going to project one of them, and then we're actually going to create a new map inside our Pro project. And that new map, we're going to make that by virtue of copying the first layer. A map gets the properties, including the spatial reference, of the first layer that's placed into it. So if I project that one agriculture layer into Albers, Africa Albers, and put that into this map that I'm just named Africa Albers or map Albers, that map is going to get that projected reference. So now how do I do that? I'm going to copy that layer from the geographic coordinate systems space in map number 1, and I'm going to paste it into map number 2. When I paste it, it's going to look slightly different. As you can see here, Kenya looks, because it's on the equator, rather elongated in this particular map projection. If I zoom out, I can see that my Albers projection looks quite a bit different from my geographic coordinate space projection, which is right here. See how different the Albers ones looks? Yeah. So the point is, I put the first layer into the new map, and now that new map has the Albers projection in it. So one way that you did it in the prior lab in the spatial reserves set is you actually projected the data for every layer. You actually ran the project tool. In this case, what I want you to do is actually just copy all of the rest of these into the Albers map, and they will be projected what's called on the fly. You're not changing the projection of them, you're casting them into, in this case, Africa Albers. Now, there are pros and cons to each method. The advantage to projecting each data set individually, like we did in the zebra mussels lesson, is that that projection is attached to that layer. It's part of that layer. When you're projecting on the fly, you're not actually changing the data sets per se, you're just casting them into a different map projection while you're working on them. So the result will be more spatially accurate measurements as we do our geoprocessing and our analysis, our spatial analysis, but the disadvantage is that you're not actually attaching the projection information to each individual layer. The advantage, though, it's a lot faster because you're just copying, as I'm doing here, all of these data layers into the map Albers map, and they'll be projected on the fly. So there's no one right way to do this. This method, I just wanted to expose you to this method as another method of working in projected coordinate space. So in sum, method A run the define projection and then the project command or tool on each individual layer. Method B, create and define one of the layers, put that layer into a new map. The map automatically gets the properties of that projected layer, and then everything else that you put on top of it gets the properties of that projection, which in our case is the Albers projection. So again, one is not necessarily better than the other. They both have their advantages. Now I've got all of those data layers inside my Albers map. And now I'm going to look at one other thing. If I zoom out to, or zoom to layer for these individual layers, they should default to Kenya because that's the spatial extent. However, water bodies, if I zoom out, notice there's something funny about this. So this is always a standard practice that I advocate people doing. Zoom out. Don't automatically assume that all these layers, is because we got them all from WRI, have the same projection attached to them. If I zoom out to water bodies, it looks like they end up at a very small part of the Earth's surface. So there's something wrong with that. What's wrong with that water bodies layer? That water bodies layer actually did not have any projection defined in the first place. In other words, it wasn't even in geographic coordinate space, GCS, WGS 84. It had no projection on it at all. So what we need to do with the water bodies is we actually need to define the projection on the water bodies. Does that make sense? In other words, every other layer that you got was geographic coordinate system. It was basically in latitude, longitude is what it was in, except for water bodies. For some reason, the people serving the data did not attach GCS to it. So if I look at source and look at extent for spatial reference for water bodies, notice it says unknown coordinate system. There's nothing defined. So it has no idea when you plop it on top of Albers how to draw that. So it draws it in a very small space in a very small part of the world, as you can see here. So now we have to define projection. Oh, I'm not spelling it correctly. You need to when you're searching on these, spell them correctly, obviously, to get to the defined projection. Okay, so now we've got defined projection, and we're going to define water bodies to be, and this is part of the lab as well, to be what it is. When you're defining projection, you want to define it to say, okay, it's unknown now, but the fact that the other ones were all geographic coordinate system, WGS 84, I'm going to bet that this should be geographic coordinate system also. It just wasn't defined. So I'm going to define it here. I'm going to pick WGS 84, geographic coordinate space, WGS 84. So I'm going to say, what you are right now, water bodies, even though ArcGIS Pro didn't recognize you, I'm going to say that you are actually geographic coordinate space, WGS 84. So I'm going to run that tool, and now it's defined. Okay, now I should be able to drag water bodies to the Albers map projection. I'm going to copy, and I'm going to zoom to layer. And now if I zoom to layer, okay, looks good now. Now it's as it should be. It should default to the extent of the country of Kenya. Okay, so now I'm going to unclick some of these. And another trick is you could actually do a control click and undo or hide or show all of the layers at once. We've got quite a few layers, and saves you some time by not clicking on every individual layer. So control click to turn them all on or off, or make them all visible or invisible. Now I'm zoomed out to water bodies, and that's great. And now I can turn on the topographic map underneath it and see, okay, water bodies is looking good now that I've defined the projection on it. Now, the next thing we need to do is to do what we did with our other layers, and that is drag water bodies over to our projected coordinate system. I'm adding now my DEM and my annual precipitation to my original map because I had not done that before. In this case, I can just drag it over from the catalog pane. I don't actually have to use the add data tool. Lots of these workflows in GIS, especially ArcGIS Pro, there's multiple ways to do most everything. Not always, but usually there's 2 ways at least of doing most anything. So now I'm going to take those 2 layers and I'm going to copy those, and then I'm going to my Albers map inside my ArcGIS Pro project, and I'm going to, as you probably suspect, I've got to go up to the actual map name. I'm going to right click there and paste those 2 layers in there. Okay, super. So we've done the downloading, we've done the projecting, and now we're ready to do a little bit of symbolization on this. And so if you want to watch a little bit more, I'm going to symbolize those layers. Here is my digital elevation model, and this is just to compare. Remember, we're in Albers, so Kenya looks a little bit stretched over the geographic coordinate space. So again, just make sure you're working in the projected coordinate space in all of your future work. So let's go ahead and change the symbology for the digital elevation model. Right now it's under stretch, and you can see this light to dark. There's not one choice that's always better for a certain layer and one choice that's always not suitable. There are certain cartographic rules, but cartographic rules are meant to be broken oftentimes. Keep that in mind as you're going forward. Here is a way to classify. I've got the elevation data, so I've got certain elevations near the coast is low or yellow and higher elevations in red. Don't really like that well. So I've got some choices here in my symbology zone inside ArcGIS Pro. I can change the color scheme. I'm still classifying the data, so there are pros and cons in even classifying the elevation data. You can leave it as continuous if you want to. We'll go back to that perhaps in a moment. But under classify, there's also a way to show. I'm going to click on show names. So this is a little bit of a guide. There's a certain set that are deemed by the programmers to be most suitable for elevation. So for example, elevation number 1 is there, and I can click on that and pick elevation number 1. This is commonly used for maps, but I've also got it under classify. So elevation number 1 is more of a continuous tone. And if I say classify, but still use the color scheme elevation, I don't really like that well. It's not really clear to me. So I can pick elevation number 1, but I really need to unclassify. In other words, I need to go to the other primary symbology and not classify. But the advantage of using classify is that you're breaking the data up into certain numbers of classes, and that might make it easier for your audience to understand. I'm going to go back to stretch though, and then go ahead and change the symbology to that elevation number 1 so you can compare the difference between classify and stretched. Stretched shows you all of the bands and just changes the color palette so that you're seeing all of the bands but not classifying them into classes. So I pick elevation number 1, and for now I'm going to go ahead and leave that. I can see the higher mountains in the southwestern part of the country showing up in this white and red, and the low elevations near the coast, the Indian Ocean in this case, as this sort of pale bluish greenish color. And in each of these, notice I've got an elevation that comes from the pixel value. So I can click on these and say that, okay, 3 is the pixel value there, or 1,000, or whatever it is, depending on where you click in the data set. It's important to know the units. So are these in feet? Are these in meters elevation? I suspect they're in meters, but we could go ahead and look at the metadata. But it's always important to know what your elevation units, or any other unit for your GIS layer, it's important to know what the units are. Let's go ahead now. We're going to go to Analysis, Geoprocessing. Let's make a hillshade. There are slope, aspect, hillshade, and other derivative products that you can make from a digital elevation model. Sometimes a hillshade is very convenient to show elevation and to show the relief of the land. Sometimes the actual raw elevations are difficult for people to interpret, and so we're going to make a hillshade here. We're going to take the azimuth, the elevation of the sun above the horizon, and the altitude. Well, the altitude is the elevation of the sun above the horizon. The azimuth is the angle at which the sun is coming from. So 315 means it's coming from the northwest. If 0 is due north, 90, for example, is due east, 180 is due south, 360 is again back to due north, 315 is coming from the northwest. If the sun were shining from the northwest at that angle, which is 45 degrees above the horizon, the hills and the mountains would look like this. Now I'm going to go ahead and turn on a few layers now that I've got that hillshade there. And I think within a few clicks of turning layers on and off, you will see that, wow, this is probably a good thing to do. So now if I drag that hillshade below the rivers, for example, you're going to be able to see those rivers moving away from the hills. Look at that. Look at that pattern. That is just right where I'm pointing my mouse right now. That's just awesome. I love that. And of course, you can adjust the hillshade and the azimuth. If you're really using this, you might want to make the sun a little bit lower, like 30 degrees above the horizon instead of 45. That would make those hills pop out a bit more. Same thing with the annual precipitation. We could symbolize that in different ways. Right now the default is this grayscale, which makes the high precipitation, annual precipitation, is bright white color, which isn't really that convenient in my opinion. So we're going to go ahead and change that. And actually here, instead of doing what we did with the DEM, left it stretched, we're actually going to classify the annual precipitation. Again, you don't have to do this, but to me it makes it a lot easier to understand classified. And I might want to make a blue tone because it's rainfall. Precipitation is often shown in a bluish tone. So I'm going to go ahead and change that. It's a bit bright or dark, if you will. It's a bit solid. So I've got a couple of choices. I could change the color palette, or I could use the transparency tool, which I think I'll do in a moment. But I'm kind of liking that right now. Again, know what the units are. I believe this is in millimeters per year from the WRI. We could look at the metadata and find out. And remember, I was saying there are several ways to do most anything in a GIS. You can go to right-click on the layer and go to transparency. There's also a appearance tab on the top that lets you go to the transparency tool right there and just slide that slider bar, and now I can make it more translucent. And now I'm seeing that the higher elevations are indeed getting more precipitation because of the orographic effect of the wind flowing over those mountains. Fascinating to be able to do this. Now, we've done some things in here, so we might want to save our project. Some data sets, some tools in a GIS are autosave and some are not, so it's important to save early and save often. Thanks for being with me. We have brought some data in from the WRI into our GIS project. We have unzipped it, we have projected it, we have symbolized it. And so now we're ready to do some more analysis on it. Thanks. I hope this was helpful.